Today we're going to have a look at the BMW S62 VANOS anti-rattle kit. So this is the spline shafts from the VANOS actuator, and you can see that there's a spline here, another spline here which engages with the sprockets. We have this threaded connection here which goes into the end of the camshaft, and these two shafts turn independently. So there's a thrust bearing in between here. These are the new ones, and it's reported this is the cause of the rattle in the VANOS unit. So what we're looking for is axial play. So axial play is in this direction, radial is in this direction, and it will move around because that's the type of bearing arrangement that we have here, but that's not really the concern. It's this movement. And you have to be really careful when you're feeling for this, because there will be an oil film in here full of engine oil. So we have to compress all the oil to get the true bottom and then pull it all the way so we get the true top, to get a feel for how much play is actually in here. So this one here, if we're careful, we can actually feel there's quite a bit, probably maybe a half a mil or so. Pick this one up, very similar. This one up, probably a little bit more, but this is all really subjective. So just out of interest, what I've got set up here is the tools which come from Beisan Systems, and there's a female section which fits onto the spline here. And then we've got a socket, a really nicely made socket actually, which comes down with the two dowel pins and engages on the cap there. So just out of interest, what I've got is set up here on the vise with a dial indicator in the tool. It's not fully clamped down, so we have to be careful when we're measuring, but what we're going to do is push it all the way down, zero the dial, and then see how much axial movement that we've got here. Right, now we're in a bit closer. Let's have a look. So we'll hold it down to stop the whole unit from coming out of the tool here. Got it pressed all the way down, and see if we can get this zeroed up. Zero, and pull it up, and we get about 0.04 millimeters. So, see that zeroed. Pull it up. 0.05. Settled. 0.05. Pretty repeatable. 0.5. So each division on the dial here is 0.01. So we're 5 divisions in, 0.05, and 10 divisions is 0.1 of a millimeter. So what we'll do is, can't get that out without resetting that. So let's see if I can get it out this way. There we go. We'll get that one out. We'll cycle through these and see if they're all the same. So this is the tool here. Internal splines, which mate really nicely with this. Minimal play there, and holds it really securely. This one here, 5, 6, 7, and 1 below 0, so that's 0.8. Now we've got 2 below 0 and 5 above. So that one's 0.08. This one's actually quite interesting because it does have a bit of a slightly gritty feel to it. There is a rough spot in there, so this one will be interesting when we pull it apart. So I'm going to put that one on this side so we know which one it is. Actually, what I'll do this the smarter way. This one here is the one that had 0.8. So I'll just put a blue dot on it. Get the next one. Point 0.8. Very safely 0.8. Give it a field test. This one also has a bit of roughness in there. Put a blue dot on this as well. So we know the ones with the blue dot has 0.8. To here. So we got 1 mark below 0 and 6 above, so that's 7. Okay, so that's the axial play measured on all 4 of these VANOS actuators. So here we are. This one's 0.7, 0.5, and these two are 0.8. So it's interesting that 2 of them have a higher axial clearance than the others. There isn't actually an OEM spec for the axial clearance, but we do have some pictures and instructions from Beisan here. Let's have a quick flick through and see if I can see what the spec is when it's fully assembled. Inspect the shaft axial play. And tightened. And it says difficult to rotate, axial's too tight, so that's preload. Doesn't really say. Oh, there we go. No axial play is considered an optimal fit, so they want it basically on the 0 mark. So let's get this out of the way, and we'll pop one open and have a look and see what it looks like inside. Grab one of the blue dot ones here. See if this was the crunchy one. A little bit of crunch. It's a blue dot one. This one has quite a bit of crunch. Let's go with that one first. Put that in there. Sockets on there. Let's put that on. Give it a go. There's plenty of Loctite on there. We can see all this white, and then here, see all this white powder that's coming out. That's the thread locking compound. So look, oh there we go, plenty loose. Get that open. Here's a grand reveal. So there's the top washer, and you can see the engine oil that's in there. So I'm going to lay this out. Put it over here. Put it here where you can see it. Lay that out there. pick that up out of there. So we have the top thrust washer. That off there. It's pretty normal, so I'm going to lay them as they would go in. So that's the thrust washer. That's the axial needle roller and cage assembly. So pull that out there. And we have the bottom shaft, just here. There. And then we have the bottom needle roller cage assembly. So grab a pick. So here we go. Just pick that out. That's the lower needle roller cage assembly. And there we've got the lower thrust washer. Here's a rag. Let's have a look. Here's the top cap. Interesting. I wonder if this has been pulled apart before in the factory, or it's been rebuilt before, because you can see here this little shiny spot here, and this one here, that looks like it was a high spot, probably when they've done this up, and it's deformed this a little bit, caused it to be raised high, and that's been rubbing on the top thrust washer. Doesn't feel like anything major, but we might give that a bit of a stone before we put it back together. That's the top one, the top cap. Here's the top thrust washer. Oh yeah, there you go. You can see where it's been rubbing there, the two high spots of the cap. Well, at least we'll know which way is the top side. Not that we're putting this back together. And you can also see the wear pattern. So if I get the light just right, there you go. You can see the wear pattern, it's not the same all the way around. And it lines up with the two shiny spots there. So, looks like it might have deformed that top washer a little bit when it's done up. Okay, so top needle roller cage. It all looks pretty straightforward, pretty clean. Got the shaft. So, looking carefully at that, you can see where it's been ground in the factory, and you can also see the wear where it's been smoothed out. So right up here on the outside you can see the original factory grinding marks, and then inside here you can see where it's polished from the rollers running. Same on the bottom side. Actually see it clearer there. So all of these little amounts of wear stack up to that increased axial clearance. But it is very minimal. You can barely feel it there. And then the lower roller cage assembly. That looks pretty good as well. So, don't know where the crunchiness was coming from. Probably just a little bit of dirt or contamination. Get all the oil out of there. Bit of stuff in there. The ring is, that bottom washer is loose in there, so it must have been surface tension holding it in. So let's see if we can pick that out. Oh, there we go. There's the outer washer. So that's the way that it was in. Now that this is offset, it should be easy to pick it out. Wow, that surface tension really stuck it in there. There we go. That's the little washer. It was installed that way, so clear it up. And you can see the running track on there. And that's the bottom where we're sitting against the housing, so that goes there. And this is the outer washer. Clean that up. And so we can see that's been moving around inside the housing here. Fretting corrosion that we've got around the outside. And a couple of marks that we can see on the inside where the thrust bearings were sitting and running. So, having a look inside here, all looks pretty good. So we'll go through, clean this up a bit better and get the new parts ready to go in. So here are the new thrust washers and outer spacer. I've taken one out already. Having a look here, it's looks internally ground, externally ground. Having a quick check on the dimensions just with a vernier, looks about the same. So inside we got 21 mil. Outside we have 25.5. 21. 25.5. Thickness is, what's that? 9.4. So this should be a little thinner. Yep. So you can see there, if I set the verniers up on the original one, 0.1 smaller, which you can see by that. And I would imagine that's to give a little bit more ability to close up the axial clearance. You can get a bit more accurate using a micrometer, but this will do for now. Okay, so what we'll do is put just a little bit of oil on here. Fit that in there. Here's the two washers. Look like they've got a pretty good surface finish. A lot of times there'll be one side that has a better chamfer than the other. So this one here looks like better chamfers on the top, so I'll put that in there. Get one of the needle roller cages. So there we are. Actually, this will be interesting to see what it is. I'll get a pair of micrometers. Okay, so here's the micrometer. It's all about the feel with the micrometer. So this one's zeroed for a hand feel as opposed to the thumb wheel. So let's have a look what we get. So, what do we got here? We've got 1, 5, 9, 1, 5, 9, 5, 6, 7, 8, 9. So here we go, we got 1.95. That one. This one. 1.94. And this is 1.96. So a little bit thicker. That's a good indicator. We'll put that all together and see how it looks. All right, we've got the lower needle roller cage assembly in. Here's the shaft, all clean, good condition. Actually, what we should do is measure this as well, just out of interest. So, don't quite have enough room to measure the unworn surface, but we should be able to capture. Yeah. So we've got 1, 2, 3, 3.4, 40, 409, 409. Yep. So that's 3.409. Put a little bit of oil on here. Turns nice and smooth. Have another needle roller cage assembly. The top washer. So same thing, there's a side with a nicer chamfer. So we'll put that one face down. Clean. Oh, it's a bit of oil. We also have to be careful not to put too much oil in here, because we'll also have to measure the free play, and we don't want that to be artificially influenced by having an oil film layer in there. One thing that we will do before we put the final screw cap back on is just use a stone here to take off that little high spot that we've got there. A little bit of light oil. So we can see now that's cleaning up all the burrs. And the high spots there have been stoned down, so we don't feel any burrs around there, which is great. Great. So give that a squirt, clean all the little bits of grinding. Stone residue off. Nice and clean. Let's put that on and have a look. I should mention as well, the threads in here have all been wire brushed out, so nice and clean, no residual Loctite. Get our little tool. Threads are lightly oiled. Get that down till it's bottomed out. And we can see. So the first step is that the cap is below the surface. We feel that nice and smooth. Both directions in axial load, and small amount, very slight. We'll just work in all the oil. Very slight amount of axial play. Okay, so we'll get our dial indicator in and see. There's no discernible play in that. With this type of thing, it's better to be a little bit on the side of caution for play, so we don't want to have preload. The preload, once it gets into zero clearance in the preload side, it's going to be very difficult to try to measure the preload, if at any. So very fractionally on the clearance side if we had to make a choice. So let's get this lined up. 0 to 0.1 max. Very good. So what we'll do is take this back out, clean the threads, put Loctite on there, and then run it back down again. It's also important when you do this to make sure that the socket face here is sitting flat against this this screw and the end nut, so that you don't accidentally slip and chew up the locating holes. That's there. Grab some Loctite. Some high strength Loctite here. Nice and tight. Zero play, and there's enough. You can tell it's right on zero preload or zero clearance, because we have the radial movement and no axial movement. So that one's good to go. Nice and smooth as well. Put that one over here and we'll keep going. There's that other blue dot one. There it is. What's interesting is you can see on the rag, you've got the standard sort of colour of engine oil, but you've also got some of the wear debris from the bearing assembly in there. So all those areas that have worn have turned into really fine particles of metal that have been encapsulated inside here, which probably leads to additional wear in. But nevertheless, the wear isn't major, and the reports were this car had a bit of VANOS rattle at idle. And so that's clean, get that in. New bearing outer collar and thrust washers. This one has similar wear. There we go. This one has similar wear to the other. Right into there. What's interesting here is we can see that this plate here was bowed a little bit proud in the center, and there's a little bit of a high spot there which has now been taken down by the stone. I might actually go a bit more because I think that center part hasn't fully flattened out. So there we go, we can see that getting a little further out. And here we go. Yeah, pretty much flat through here, so give it one more go and then clean it up, put it back. Here we are. So, same deal. This one's all been cleaned. Get that in. Nice and smooth. Feels like zero end play. Still plenty of free play there. Essentially zero. Great. So let's have a look. On the underside, we can also see two rub marks there and there. Interestingly, this one also has a bit of a step worn in it. So you can actually feel we have a look here. This is the top side, this is the bottom side. You can see there's two marks here. And we can also see a bit of a burr here from the thread. And there's also, this side here doesn't have a step. This side does. There's a discernible step in there. That'll be interesting when we stone that. Put that there, get these off. Got the top washer. So that's the top washer, that's the needle roller cage. That's the center axle. Lower thrust. Same sort of thing. This one actually has quite a bit more threading on the outside of this ring. And get that last ring out. It's there. Clean it out. Looking good. So, same. Get another new set here. Oil. That washer is seated and the outer ring is pressed down fully. So that's important. Needle roller cage. There. Same sort of wear as the other ones. There and there. One more needle roller cage. And top washer. Turning nicely. Okay, let's have a closer look at this. So that's the underside that we saw before. There's the top side. So first up, not too bad. That lip there seems to have come down pretty easily. That's cleaned up pretty well. We can see the center part and that lip at the outer edge. And where's that burr? The burr where the thread started on the end cover, on this end nut. So get the feeling this nut's a little bit soft in its material. Nice and clean. Looking good. Get it in for the trial assembly. Negligible play. Very good. Plenty of movement. Radial direction. Smooth. No axial play. So, top nut. This one looks pretty good, no burrs, no real issues. Got the washer, center shaft, lower bearing. Check the chamfer. It in. Squirt of oil. Needle roller cage. center shaft. Again, same sort of wear. Need a roller cage. Thrust washer. A little bit of stoning for the top nut. Clean up really easily.